Our lesson 8.3 is about series and parallel circuits electrical connections. Lesson 8.3 has the following goals. Explain the series and parallel electrical circuits and to solve problems involving current, voltage, and resistance in series circuits and parallel circuits. There are two types of circuits. The series circuit, it provides only one possible path for the flow of current, whereas the parallel circuit offers more than one path for the flow of electricity. A string of Christmas lights is an example of a series circuit. When one burns out, the circuit is broken and none of the lights will work. In series circuits, current can only take one path. The amount of current is the same at all points in a series circuit. This table shows the characteristics of series circuits. In series circuits, the total current is equal to the individual currents. That is, I sub t equals I sub 1 equals I sub 2 equals I sub 3 and so on. The equivalent or total resistance is obtained by adding all the resistances. That is, R sub t equals R sub 1 plus R sub 2 plus R sub 3 plus and so on. And the voltage total is obtained by adding all the voltages in the resistors. So V sub total equals V sub 1 plus V sub 2 plus V sub 3 and so on. In a parallel circuit, each load has its own path for electricity. All the appliances in your house are connected in parallel with each other. So each is subject to the same supply of voltage, and if one stops working, the others continue to work. In a car, for example, the electrical system is connected in parallel. We have the source, the battery, then the dome light, headlights, horn, starter motor, radio, and so on are all connected in parallel. Here is a comparison of series and of parallel circuits. For the series circuit, the total current is just equal to the individual currents, while in parallel, the total current is equal to the sum of the individual currents. In a series circuit, the equivalent or total resistance is the sum of all the resistances. While to solve for the equivalent or total resistance in parallel connection, we first find the reciprocal of the total resistance, which is equal to the sum of the reciprocals of the resistances, or 1 over R sub t equals 1 over R1 plus 1 over R sub 2 plus 1 over R sub 3 plus and so on. For the voltage, in the series connection, the total voltage equals the sum of the individual voltages, while in parallel connection, the total voltage is just the same as the individual voltages. Now let us do some examples. Example number 1. How much current flows in a circuit with R1 equals 5 ohms, R sub 2 equals 13 ohms, R sub 3 equals 12 ohms, and R sub 4 equals 14 ohms, and the voltage source is 90 volts. As can be seen in the figure, the connection is a series circuit. So, using Ohm's law, the formula to find the current is I sub t equals V sub t over R sub t, where our total voltage is 90 volts The total resistance is the sum of these resistances. 5 plus 13 plus 12 plus 14 equals 44 ohms. Therefore, the total current equals V sub t over R sub t. Substituting the values and simplifying, the answer is 2.04 amperes. Example number 2. Find the value of the voltage source in the circuit if R1 equals 5 ohms, R sub 2 equals 13 ohms, R sub 3 equals 12 ohms, R sub 4 equals 14 ohms, and the current flowing is 1.5 amperes. Again, the connection is a series connection. So, using the formula V sub t equals I sub t times R sub t, where the total resistance is the sum of the resistances, which is equal to 14 ohms. And the total current flowing is 1.5 amperes. Thus, the value of the voltage is obtained using Ohm's law. V sub t equals I sub t times R sub t. Substituting the values, the answer is 66. Example number 3. Find the total value of R3 if R1 equals 3 ohms, R2 equals 2 ohms. The total current flowing is 8 amperes and the voltage source is 80 volts. Again, the connection is a series connection. So, here we are given the total current is 8 amperes, the total voltage is 80 volts, and we are required to find the resistance in resistor number 3. First, we solve for RT from the formula R sub t equals V sub t over I sub t. And substituting the values, 80 over 8 equals 10 ohms. Now, using the formula R total equals R1 plus R2 plus R3, rearranging and solving for R3, R3 equals R total minus R1 minus R2, and substituting the values, 10 minus 3 minus 2 equals 5 ohms. Example number 4. The load across a battery consists of 4 resistors with values of 15 ohms, 45 ohms, 22 ohms, and 28 ohms connected in series. Draw the circuit diagram and label completely. What is the total resistance of the load? What is the voltage of the battery if the current in the circuit is 0.1 amperes? So, solution. We have here the circuit diagram of the given problem. The total current is 0.1 amp. Resistance 1 has 15 ohms. Resistance 2 has 45 ohms. Resistance 3 has 22 ohms. And resistance 4 has 28 ohms. The total resistance is obtained by adding these 4 resistances. You have 15 plus 45 plus 22 plus 28 equals 110 ohms. Therefore, the total voltage is obtained by using the Ohm's law. We have V sub total equals I total times R total, or substituting the values, we have 0.1 times 110 equals 11 volts. Example number 5. How much current flows in a circuit with R1 equals 5 ohms, R sub 2 equals 13 ohms, R sub 3 equals 12 ohms, R sub 4 equals 14 ohms, and the voltage source is 90 volts. As can be seen in the figure, the connection is parallel. Therefore, the total resistance is obtained by solving RT from this formula. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R sub 3 plus 1 over R sub 4. Substituting the values, we have 1 over RT equals 1 over 5 plus 1 over 13 plus 1 over 12 plus 1 over 14. And simplifying, we have 1 over RT equals 0.4316. Taking the reciprocal, R sub T equals 1 over 0.4316, and that gives us 2.32 ohms. Thus, solving for I sub T is V sub T over R sub T equals 90.0 divided by 2.32 is 38.79 amperes. Example number 6. Find the value of the voltage source in the circuit if R1 equals 5 ohms, R sub 2 equals 13 ohms, R sub 3 equals 12 ohms, and the current flowing is 12 amperes. Again, the connection is parallel, so we can solve for R sub total by using the formula 1 over R sub t equals 1 over R1 plus 1 over R2 plus 1 over R3. Substituting the values and simplifying, we get 1 over R sub t equals 0.3602. And taking the reciprocal, R sub t equals 1 over 0.3602 equals 2.78 ohms. Solving for the total voltage, V sub t equals I sub t times RT, and substituting the values, the answer is 33.36 volts. Example number 7. Find the value of R3 if R1 equals 4 ohms, R sub 2 equals 2 ohms. The total current flowing is 10 amps and the voltage source is 12 volts. So again, this is a parallel connection. So we can use first the Ohm's law to find the RT from the formula V sub t equals IT times RT. Rearranging, we have RT equals V sub t over IT, and substituting the values, V sub t is 12 divided by 10 equals 1.2 ohms. Since the circuit has a parallel connection, R sub t can also be found from 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And substituting the known values and simplifying, we have 1 over 1.2 equals 1 over 4 plus 1 over 2 plus 1 over R3. Solving for 1 over R3, we get 1 over R3 is 0.083. Thus, taking the reciprocal, R3 is 12.05 ohms. Example number 8. Occasionally, you may encounter circuit diagrams that are not drawn very neatly, such as the diagram shown below. This circuit diagram looks more like how a real circuit might appear on the lab bench. What is the equivalent resistance for the resistors in this diagram? Assuming each resistor is 10 ohms and the voltage rating of the battery is 12 volts. Solution. We redraw the diagram by considering that the resistors R1, R2, and R4 constitute a path from the positive terminal of the battery to the negative terminal. In parallel with this circuit are the resistors R3 and R5, which constitute another path from the positive to negative terminal of the battery. These paths are shown more cleanly drawn in the circuit diagram below. Now we see that R1 and R2 are in parallel and the parallel connection is in series with R4. Solving for the equivalent resistance for R1, R2, and R4, we get R124 equals 1 over R1 plus 1 over R2 plus R4. So substituting the values and simplifying, we get the equivalent resistance for resistors R1, R2, and R4 is 15 ohms. For resistors R3 and R5, which are connected in series, the equivalent resistance is R35 equals R3 plus R5, or 10 plus 10 equals 20 ohms. The new circuit diagram can be drawn as in the figure below. So in this figure, R124 is in parallel with R35. So solving for the equivalent resistance of the whole circuit, it is RT equals 1 all over 1 over 124 plus 1 over R35, and substituting the values, we get 8.55 ohms as the total resistance of the circuit. Thanks for watching.